So you're working on a really critical part, right?
Yeah.
And you need it absolutely spot on with every single tool change on your CNC lathe.
Mm-hmm.
Ever find yourself wondering if those, I don't know, tiny little shifts might be affecting your final precision? Like, what's really going on when one tool swaps out for another?
Yeah, that's a common thought. And it's exactly the puzzle we're tackling today.
No.
We're doing a deep dive into CNC lathe turrets, specifically pitting hydraulic against servo systems.
Okay.
We want to see which technology, truly reigns supreme when it comes down to indexing accuracy and just doing the same thing perfectly over and over again, repeatability.
Right, repeatability, that's key.
Exactly. So whether you're a seasoned machinist actually weighing these options for a new machine, or maybe you're just curious about the mechanics behind it all.
Which many people are.
Right. Understanding the core differences between hydraulic and servo turrets is pretty essential. Our aim here in this deep dive is basically to break down these two systems, highlight their fundamental distinctions, and, well, ultimately clarify which one gives you that edge when you're really chasing those ultra-tight tolerances.
And we've got some good insights for this.
We do. We've tapped into some fantastic real-world stuff, including some practical experience shared by the folks over at J&M Machine Tools to try and bring a clear picture.
Excellent. Okay, let's jump right in then. When your absolute focus is getting the highest possible accuracy and that kind of rock-solid consistency doing the exact same thing every time, which type of turret, generally speaking, comes out on top?
Well, the immediate answer, generally, is that servo turrets typically provide superior indexing accuracy and repeatability.
Okay. Servo. Why is that?
What's really interesting is the reason behind it. Servo systems, you see, rely on incredibly precise servo motors. But crucially, they also incorporate encoder feedback.
Encoder feedback, what's that exactly?
It's essentially a sensor. Think of it like that. It precisely measures the turret's actual position. This lets the system constantly monitor where it is and make tiny, tiny adjustments in real time.
Ah, okay.
We're often talking positioning accuracy within hundredths of a millimeter.
The turrets, that's tiny.
It really is. And that level of fine-tuned control, well, it generally just exceeds the capabilities you find in the more, let's say, mechanical positioning of hydraulic systems.
Right.
And, this jump in accuracy with servos, it can honestly be the difference between qualifying for those high-margin, tight-tolerance contracts and maybe being limited to more general work.
Hundredths of a millimeter. That kind of precision is almost hard to believe. So what's the core tech making that possible? You mentioned closed-loop control. Can you maybe break that down a bit more?
Sure. Think of closed-loop control like a system that's constantly checking its own work, its progress, and correcting course if needed.
Yeah.
In a servo system, that encoder we just mentioned, it acts kind of like its eyes.
Right.
It's constantly reporting the actual position of the turret right back to the machine's control unit.
Gotcha.
And then the control unit compares this real-time info with where it's supposed to be the commanded position and makes any necessary tweaks to the servo motor to make sure it's precisely where it needs to be.
So it's always adjusting.
Constantly. Hydraulic systems, while, look, they're very powerful, they don't typically have this continuous direct feedback mechanism checking their precise angular position in quite the same detailed way.
Okay, that makes perfect sense. So servo generally leads on accuracy, but how do these two types actually do the work? Spinning the turret and locking the tools in place, what are the actual mechanics?
Yeah, that's a really key distinction because their underlying actuation methods are quite different.
Right.
Servo turrets, as we sort of touched on, often operate as what you might call a hybrid system.
Hybrid? How so?
Well, the highly accurate indexing motion, that precise rotation to get the right tool in position that's driven by the electric servo motor we talked about.
The precision part.
Exactly. But the significant force you need to actually clamp and securely hold the tool holder during the cut, that often comes from a separate hydraulic system, or sometimes even a pneumatic one.
Ah, interesting. So different power sources for different jobs.
Precisely. This separation of indexing and clamping, it can be quite advantageous. It allows for things like more tool stations on the turret and the ability to handle more complex machining tasks because you've got that fine-tuned positioning.
So it's a hybrid system. You get the precise movement handled electrically, and then the heavy-duty holding power from fluid or air. Accuracy where you need it for position, muscle where you need it for stability during the cut.
You've got it. That combination offers a great deal of flexibility. Now, contrast that with hydraulic turrets.
Okay.
They represent a more, let's say, traditional approach. It's all based on fluid power.
Right.
So you have an electric motor driving a hydraulic pump. This pump generates high-pressure oil. Yeah. And this pressurized hydraulic fluid is then used for both things, rotating the turret to the desired tool, and for applying the clamping force to hold that tool rigidly.
So one system does both the jobs.
Yes, and valves play a crucial role here. They direct the flow of this high-pressure oil to the right cylinders and actuators at the right time. So with hydraulics, both rotation and clamping are powered by that single hydraulic system.
Okay, so hydraulics is all about using that fluid power for both moving and holding. That sounds like it could deliver some pretty serious clamping force.
Oh, it certainly can. Hydraulic systems are known for generating substantial clamping force.
Which is good for.
It makes them particularly well-suited for really heavy-duty machining applications. Think about working with, large, heavy workpieces.
Okay, gears or something.
Exactly, like substantial gears or maybe long shafts. In those situations, you absolutely need that exceptional clamping rigidity to minimize vibration and ensure the cutting process is stable and accurate.
Makes sense.
So, while the basic concept of a hydraulic turret might be simpler in some ways, they just don't offer the same level of electronic flexibility and that fine positional control you get with a servo system.
Okay, got it. Accuracy and how they physically work, check. Now let's talk speed. Because, in manufacturing, time really is money.
Absolutely.
How do hydraulic and servo turrets compare when it comes to how fast they can index, go from one tool to the next?
Yeah, this is another area with a pretty clear difference.
Yeah.
If you're looking to minimize those non-cutting times, the time spent not actually making chips.
Which everyone is.
Right. Then servo turrets are definitely the front runners. They index significantly faster than hydraulic turrets.
Significantly faster. Why?
The key factor is the rapid electronic response of that servo motor.
Yeah.
It just reacts instantly.
Okay.
This quick movement drastically cuts down the time spent between cuts, which, like you said, directly translates to higher throughput. Especially important in jobs needing frequent tool changes.
And hydraulics are slower because...
Yeah. Well, hydraulic systems inherently have slower response times. It's down to the physics of fluids, really. It takes time for valves to actuate, for pressure to build up or release enough to move the mass of the turret.
So it's basically the difference between sending an instantaneous electrical signal versus waiting for hydraulic fluid to physically move and build pressure.
That's a pretty good way to put it, yeah.
Yeah.
To give you some concrete numbers, servo tool changes, they can often happen in well under 0.15 seconds.
Wow, that fast.
Incredibly fast. And because it's all electronically controlled, the servo motor can accelerate rapidly, move to the exact programmed position, and then decelerate just as quickly and smoothly. And this ability to jump to pretty much any tool position almost instantly, that offers a huge efficiency advantage for complex parts or in high-speed machining.
And hydraulics.
Now compare that to hydraulic turrets. You're typically looking at indexing times more in the range of, say, 0.15 to 0.25 seconds, maybe even longer, depending on the specific design and size.
Okay, so maybe a tenth of a second or more difference per change?
Exactly. And while those fractions of a second might seem tiny for just one tool change,
They add up.
they really accumulate significantly over a long production run. No doubt about it. So for applications where speed is really critical for your cycle time, servo technology is the definite leader.
Speed is crucial, definitely. And so is managing operational costs. We all know energy costs in a busy workshop can be substantial. Are there big differences in how much power these two types of turrets typically use?
Absolutely. And this is another important area where, again, servo turrets tend to offer a notable advantage: energy efficiency.
Okay, how so?
The fundamental difference is really in their power consumption patterns. Servo turrets primarily draw electrical power only when they're actively indexing. It's more of an on-demand system.
Right.
When the turret is just sitting there, stationary, no tool change happening, the power consumption is minimal. It's kind of like a light switch. Power gets used when it's needed to do something and very little when it's not.
So it's only really using significant energy when it's actually moving the turret.
Precisely. Now, contrast that with many typical hydraulic systems. Often, the hydraulic pump motor runs continuously, basically whenever the CNC machine itself is powered on.
Even if the turret isn't moving?
Yeah, just to maintain the necessary hydraulic pressure throughout the whole system, even when the turret is completely idle, doing nothing.
Ah, I see. That sounds wasteful.
Well, this continuous operation of the pump, regardless of whether a tool change is actually happening, it leads to a significant amount of energy being consumed, potentially wasted, over the course of a shift, or a day, or a week. So opting for a servo turret can therefore result in pretty tangible savings on your electricity bill. And, it also aligns better with sustainable manufacturing practices, which is increasingly important.
Yeah, that's right.
The potential for long-term energy cost reduction can be quite substantial.
Reduced energy costs, that's always going to be a welcome benefit. Okay, let's get down to brass tacks then. The money. The initial investment needed for these systems and maybe the ongoing expenses, keeping them running smoothly over the long haul. How do they stack up on cost?
Yeah, this is often where you see a bit of a trade-off, and it becomes a key part of the decision-making. Hydraulic turrets typically, um, they have a lower initial purchase price compared to servo
Okay,
turrets.
cheaper upfront.
Generally, yes. The underlying technology is more mature, perhaps less complex electronically in some ways.
Mm-hmm.
This can make them an appealing option for businesses really focused on minimizing that upfront capital spending,
Right.
particularly if they're doing more, let's say, general machining tasks, like maybe standard automotive parts, things like that.
So a lighter hit to the wallet right at the start, but what about the bigger picture? The total cost of ownership over the life of the machine.
That's where the long-term advantages of servo turrets often start to look more attractive. We've already talked about the potential for significant energy savings,
Right, the electricity bill.
and that definitely contributes substantially to the long-term cost picture. But there are other important factors too. Think about maintenance.
Okay.
Servo systems generally require less routine upkeep compared to hydraulic systems. You just don't have the ongoing tasks associated with hydraulic fluids.
Like what?
Well, regular oil changes, filter replacements, worrying about potential leaks from hydraulic seals, which can degrade performance over time and frankly be costly to fix.
Right. Less messy too, probably.
Definitely less mess, fewer fluids to constantly monitor and maintain. Well, look, servo systems do involve more sophisticated electronics.
Sure.
They typically require less of that regular hands-on fluid-related maintenance that's just inherent to hydraulic systems.
Okay, so lower running costs potentially from energy and less routine maintenance. What else?
Well, you factor in the performance benefits we discussed, the enhanced productivity and precision that servo turrets offer.
Faster cycles, better accuracy.
Exactly.
Yeah.
Faster cycle times mean more parts produced per shift. The reduction in rejected parts because of improved accuracy that saves material and time.
Mm-hmm.
And maybe even the ability to take on more intricate, higher precision jobs, things like aerospace or medical device components. That can open up opportunities for higher margin work.
So it could potentially earn more money too.
That's the idea. So while yes, the initial investment for a servo turret might be higher, the potential for lower running costs combined with superior overall performance, well, it can often justify that initial expense.
Makes sense.
It can provide a better return on investment over the long term, especially if you're in a production environment where precision and high volumes are really critical.
Okay, great. So let's maybe try and summarize our deep dive into these turret technologies. It sounds like when ultimate accuracy and that consistent repeatability are the absolute top priorities, servo turrets generally lead the pack, mainly thanks to those closed-loop control systems with the encoders.
Yeah.
They also seem to offer pretty significant advantages in terms of indexing speed, getting tools changed faster, and being more energy efficient.
Yeah, correct, on all accounts.
Hydraulic turrets, on the other hand, they typically come with a lower initial purchase price, which is attractive.
A big factor for many.
And they provide that really robust power, that heavy clamping force that's often needed for very heavy-duty machining jobs.
That's an excellent summary. Yeah, you've captured the key differentiating factors really well there.
Great. So thinking about our listeners as they're evaluating options maybe for their next CNC lathe or even just thinking about the tech in their existing machines, the central question really seems to come down to understanding the specific demands of their particular operation.
Absolutely. It's not one size fits all.
Right. Like what kind of parts are you actually machining day to day? And what are your budgetary constraints looking like? Are you prioritizing that absolute micron level precision above everything else?
Or maybe.
Or is maximizing production speed, just getting parts out the door faster, your number one goal? Are energy savings a major consideration for your business's bottom line? Or perhaps is that initial capital outlay, that upfront cost, the most significant hurdle you need to overcome?
Exactly. Carefully considering these specific needs and priorities, the unique demands of your work and your financial situation, that should ultimately guide your decision when you're choosing between the high precision capabilities of servo technology and the, let's say, more traditional power of hydraulics.
Which brings us maybe to a final thought for everyone listening.
Yeah, think about this. Considering your specific machining needs, your business goals, which single advantage we've talked about would it be the superior precision, the faster cycle times, the significant energy savings, or maybe that lower initial investment, which one would have the most substantial positive impact on your operations?
That's a great question to ponder.
Answering that, really drilling down into what matters most to you, that's essential for figuring out which turret technology is truly the right fit for your particular circumstances.